Hey guys, it's IDW, and today I'm going to be starting a new series in which I'm going to be basically going over how addition works from the very basics in terms of redstone and also in real electronics. So these two logic gates are really all you're going to need to know, other than maybe some basic geometry, like you want to know proofs and such. And then again, you won't really need to know that, but yeah, just if you want to it'll be a bit easier if you know proofs. I guess I can explain them along the way. But anyways, so right here, this is basically, as I said, all you really need to know. You need to know that this will only turn on if you have those on, and you'll need to know that this will only turn on when this is off. So, yeah, that's basically all you really need to know. You could find these two logic gates, the AND and the inverter, anywhere on YouTube. Anyone who does any sort of redstone should explain them, so I'm not going to go over them. But yeah. So first of all, what exactly are we trying to build in this series? And the answer is something that's going to be able to do math for us. But there's a whole lot of problems with this. First of all, how do we convert just a wire that can be on or off into something that will send data? Well, right now, we only have two pieces of data that we can actually send with this. And the way that that you can really think about this is how many pieces of data can we have in one digit of information in the numbers that we would use in our heads. We can have up to 10 different numerals, but we only have two different states here. So that means that rather than having a base 10 system, we're going to have a base 2 system. Now, this may be a bit difficult for you to wrap your mind around, so I'm just going to add another wire. And I'm just going to say that this right here is going to be worth 0. If I add this one on, then this is the maximum that I can count to currently, because I'm just going to say that this is going to equal 1. But if I want to add one more again, then I'm going to have problems, because I'm going to only be able to, I can only represent two pieces, and I know that this is already a 0. So what I'm going to have to do, what you do in a situation like this, is you just carry it over to the next bit, or digit, technically. So right here, this is how I would represent 2. So this is basically a 10, right? In terms of this base 2 counting system. But now we want to add one more to this. And if we flip this off, then this is going to be off as well, and we're only going to have a 0 again. That's already taken. So what we have to do is we're going to have to turn this one on, since that's the only thing that we can really do. So what this basically means is that there's 4 different results that we can get. Well, 4 different situations that you can get with 2 digits. Just like there's 10 different situations that you could get with 2 digits of decimal. And those are all 4. So if I was to add a third one on, if we had 10 digits, we could get all the way up to 100. But once again, we can only represent 2 numbers instead of 10 different ones with each wire, or digit in this case. So that means that we can get up to 8, and it just keeps going up by powers of 2. So the number of different states that you can represent with one wire is going to be 2. The number that you can represent with 2 is going to be 2 to the second, which is 4. And the number that you can represent with 3 wires is going to be 2 to the third, which is 8. And if I was to add on another wire, or digit, then I could get 2 to the fourth, which is 16, and so on and so on and so on and so on, towards infinity. And this is actually the way that the computer that you are watching this video on is representing every single pixel in that screen. Every single one of them is represented as a number in 8 different digits. So that's a number between 1 and 255. Since that's 2 to the 8th power. So yeah, this is how we're going to end up actually representing numbers. Now we could just say that this is 1, and this is 2, and this is 3, but it actually turns out that with numbers like this, well, we don't actually have a number for 11, just because it saves space, first of all, and second of all, it's much easier, I didn't mean to do that, it's much easier to actually do math like this. I mean, if you were to set up a normal addition problem like 2 and 1 plus 1, let's just build that like that. Then if I was to just use a different wire for each one, then that would be really inefficient, because then I would just have to move this over. And what happens if I have to do, say, this to it? Then I have to move it over to the third one. And in terms of actually building something with redstone like this, it's actually much, much, much easier to just go with this base 2 counting system, which, by the way, is called binary. I think you probably guessed that from the example that I gave of it. But yeah, that's basically how to think about binary. It's a bit difficult to get your grasp around it when you first look at it, but after a bit, you'll start to get it. So yeah, in the next video, I'm going to actually start getting into how we're going to actually use such numbers to add two numbers together in this counting system. But once again, you could not, we needed to have a way to represent our numbers. So bye!